Good evening, ladies and gentlemen. You're very welcome to Fieldfisher London. My name is Phelim O'Queeve and I'm the head of Renewables in Fieldfisher Dublin. And obviously, you know, we're here to talk about floating offshore wind. So we have a good few people in the room, and then we have a lot more attending online. So you're all very welcome. Before we jump into it, I'm just going to talk a little bit about Fieldfisher. Inevitably, a solicitor or lawyer is always going to do a sales pitch. So here you are. We are 1,700 people strong. We are in 26 cities around the world. So we have very much a pan-European presence. So before we get into matters, I want to tell you a story. It's about a planet where the rivers were clear and the oceans and the seas were deep blue and the air was clean. Now everything was going swimmingly until this guy came along. So he got cold and he discovered a fire. Now, boy, did he love fire, because he's been burning shit ever since. Now, he had to eat, so he hunted, and eventually he tilled the land and agriculture was invented. Things continued like that for a long time. Eventually, he and people just like him congregated in communities and villages and towns, and building commenced. Now, they built large buildings and small buildings and impressive structures like the pyramids. And to provide water to their towns, they built aqueducts and many other wonders. But all these things were built with the efforts of man and beast. And they were thinking, well, how can we do this better? How can we do this more efficiently? So they discovered a substance called coal, which they extracted out of the ground, and it was used to produce heat and energy and power. And that gave rise to an industrial revolution and a transport revolution. But they were always looking for ways to do this more efficiently. So they came across a thing called oil, a sticky substance, and it was much more efficient than coal. Firstly, they extracted it in small quantities, but soon they were doing that at a massive scale. And almost everybody became entirely reliant on it. And all the while, agriculture continued to evolve and become industrialized. So much so that there are now currently 1 billion head of cattle and cows in the world. Now, while all this was going on the plus side, there were renewable energy sources being developed, but not on the scale required. So carbon emissions went through the roof. Currently, 35 gigatons of carbon are emitted in the world every year. So as a result of this, the world started to look a little bit like this. And in some cities, the air was like this. And the ice packs started to melt, and glaciers melted, and sea levels rose. But a lot of people saw this coming, and they objected to the way things were going. And so they campaigned. And some people led that debate, and some people denied that debate. So that brings us to now and where we are now. Now we need to imagine a new climate story. Now, no single technology offers the perfect solution to our problems. But given the extent of the planet's oceans and seas, floating wind can be a game changer. And that's what we're here to discuss right now. So this evening, you're going to hear from the Simply Blue team, you're going to hear from Green Giraffe, and you're going to hear from RCG, and indeed Fieldfisher. So we're going to hear from Sam Roach Parks and Hugh Kelly. They're going to give a commercial perspective and ask the all-important question, why? Why floating wind? Then we're going to hear from the Green Giraffe team. We're going to hear from Michael Chappell on bankability and risk analysis. And we're going to hear from Clement Weber in relation to how you finance floating wind. And then my partner, Elaine Traynor, is going to look at legal risks. And then Dan Spearman of RCG is going to discuss floating wind technology. So can I just say, before I hand over to them, I've been in the trenches with these guys. I've done deals with these guys, and they know what they're talking about. So at the end, then we will have a panel Q&A. So without further ado, I'm going to hand over to Sam.
Thanks, Phelim. I thought my job was the story. I didn't realize you were going to tell the story. And about the cows bit, that was a bit hard. I am a beef farmer, but we've cut down a lot in numbers, so we're doing our little bit. Thanks to Phelim and Clement for inviting Hugh and I here this evening, and especially thanks to all the Fieldfisher team and the Green Giraffe team for being in the trenches with us over the last couple of years and fighting with us for the expansion that we've gone through recently. This is my first week away on a business trip since the madness began in March 2020, and leaving home, small village of Ardmore, on Monday morning, driving up to the airport. To be really honest, I wasn't a happy lad. I spent the last 2 days or 3 days in Scotland, and even just meeting a couple of people here this evening, putting names to faces, I now realise why we're doing it, because we have to do it. You pointed that out, Phelim. And the energy up in Glasgow and what we're doing here is so important. And we're at a time in our careers where we have to do this. We can't leave it to the young people and the older people. Whatever. We must do this right now. Two things I just want to talk just briefly about before I hand over to Billy on the video to show maybe the why bit of what we're doing as a blue economy developer. And two changes I've noticed. The first change in floating wind over the last 18 to 24 months. After 2 days of meetings and sessions and receptions afterwards, which is great, I never heard the word technology readiness and floating wind. Heard lots of other words. Ambition. 70% circa of ScotWind is deep water. We've seen what President Biden announced in the US. Of course, I heard the word challenge, you know, regulation challenge, local supply chain, the obvious port infrastructure. I think really the big one that came out of the last couple of days, and we were just chatting about back there, was actually human resources, us. And there's a limited amount, and we're all jumping around. No one's given, I haven't got the call yet for the CV, but it's there if anybody wants to give me a shout. And that's a huge challenge. And of course, lots are looking to transition from oil and gas and from other parts of other industries. And that's going to take time, and we've got to acknowledge that, and that needs to really, really increase. The other change I just want to quickly tell you about is the change in Simply Blue. We're now about 50 people. We're still a small entrepreneurial early stage developer. We have just over 9 gigawatts of projects in early stage development, including a project in Ireland, Emerald, with our partner Shell. It's a lovely story of the energy transition. The Kinsale gas fields at present are being decommissioned, moving into renewable energy. Our head office is in Cork. We just started a small office in Dublin in a very convenient location. I was wondering why it was convenient. Then Hugh and Patricia told me it was beside the restaurant with the best wine menu. So I'm glad we've got our priorities right. We have a project in Scotland called Salamander. And it's a stepping stone project. And it's really important, I believe, between the two pilots that are in Scotland and the commercial scale projects that are coming through in ScotWind. It's also really interesting what's happening in hydrogen, and maybe that's what these early stage projects could do. We have projects down in the southwest with our friends and partners Total Energy. I don't think Mike Scott could make it this evening, but we've got an office in Pembroke and we have an office in Newquay, so it's like a pincer movement for our Blue Gem Wind project down there, Erebus and Valoris, which we're bringing through to the market. Erebus might be the biggest in 2025, 26 actually commissioned. It'll certainly be up there. And we're delighted to have just concluded and expanded our partnership with Total in the US. We've got great people over there. And again, going back to what President Biden announced, that's huge. This is a huge challenge that we all have got to try and grab and figure out how to do it. Lastly, I think as blue economy developers, we're property developers by trade. We're just looking out now. There's three things that we really talk about and think about. One is multi-use of space. A happy coexistence is one of our colleagues talks about. The second is biodiversity. So between these platforms, there's a large amount of real estate. So we're looking at sustainable aquaculture, seaweed farming, and that's hugely important. And lastly is the revival of the coastal community. And that just transition. Back to my little village, and I said this earlier in the week, In the 1970s, there were 13 families making their living from small scale fishing. There's one and a bit today. So I think it's all our responsibility to get together, and there's so much there, we must work together. Because the just transition is also a huge part. Billy, I'm going to hand over to you to play our kind of introduction film from Simply Blue. Thank you.
For millennia, humanity has relied upon the oceans. They have fed us. They have carried us to distant lands. They have entertained us. They have cleansed our air and absorbed our waste. Once again, we need their help. This time to address our climate, food and biodiversity crisis, and to save our planet as we know it. We are part of a movement. Some are working with rainforests, some with cities, some with the land. We are working with the oceans. We develop pioneering blue economy projects, floating offshore wind, wave energy, and low-impact aquaculture, all in harmony with the oceans. We are committed to creating new economic opportunities for coastal communities and to developing projects that coexist with sustainable fisheries and marine conservation. We believe in the power of the oceans to decarbonize our world. We are Simply Blue.
A brief intro to Simply Blue and what drives us and the destination we hope our work will help us reach. We, Sam and myself, are always struck by the passion and creativity of the entrepreneurs and people we work with in the renewable energy space, and their fabulously creative ideas. From industrial scale carbon capture to hydrogen production to manufacturing cement inside bags so that we can capture the carbon as it's produced, to producing paints and roof tiles that can turn whole surfaces, whole walls into energy generators. Indeed, a lot of the ideas are completely off the wall, but all are thought-provoking and offer endless inspiration to Sam and to me. At Simply Blue, as you've seen, we've chosen our focus, and that's on the marine environment, and in particular, but not exclusively, on floating offshore wind. There are many arguments in favor of floating offshore wind. Phelim mentioned a few earlier. They're all well aired and well established, so I'm not going to repeat them here. But what is perhaps most important is that it will soon deliver affordable, clean energy at significant scale. It'll procure or produce significant economic benefit for local economies and coastal communities, and it'll make a significant contribution to the fight against climate change. The argument for action has largely been won amongst the public. Recent survey that was interesting by Peugeot found that 40% of UK parents now want their children to learn to drive in electric vehicles, skipping entirely the experience of diesel and petrol. And another global survey found recently that 58% of people want their country to be a leader in setting ambitious climate targets at COP26. That's up from 43% before Paris. And so while there's still a lot of undecideds, the number opposing any international agreement has at last become vanishingly small. So Simply Blue, we applaud the enabling actions and the ambitious goals that have been set by governments to date. MARA, with the institute, the body set up by the Irish government, and the announcement last Saturday, I think it was, by the UK government of 160 million to support the building of floating wind farms off Scotland and Wales are just two examples. But to unleash the full potential of floating wind as quickly as possible, and to be frank, as quickly as needed, we also need to see policies and legislation that reflect the increasing urgency of the situation in which our world finds itself. Perfect is the enemy of good. Perfection is unachievable. It's a journey, not a destination, and that must be recognized. Yeah, frameworks are essential to prevent serious mistakes being made, opportunities to develop floating wind at scale being squandered, or local economic benefits being lost because the pace is too slow. But unnecessary obstacles to development need to be removed. I recall I saw a sign once outside a garage. It said, cheap, fast, quality. It then went on to point out that you can pick any two, but you can't have all three. Against the backdrop of the current climate emergency, short-term adherence to ruthless market economics that prioritizes cost minimization must not be allowed to jeopardize us addressing the medium-term climate risks that are accelerating towards us. COP26 wants to limit global warming to 5 degrees centigrade. Doesn't sound like much. It's sobering to think that during the last ice age, the mean global temperature of the Earth was only 5 degrees less than it is today. That's how sensitive our ecosystem is. So 1.5 degrees, that's huge compared to 5 degrees. This urgency presents a serious challenge, particularly for democracies that are used to compromise and the delays that compromise always deliver. It requires new levels of bravery and vision from our political leaders, but this time the voters are aligned behind them. And we're beginning at last to see some political champions emerging. What Simply Blue looks to identify, and getting to the subject of this seminar and bankability, what we look to identify in new project development opportunities and in new geographies, when we're looking at them, sure, we assess the technical constraints, but we look just as hard at the political and regulatory landscape. We look for nations that are genuinely committed to working with developers to help them fight against climate change. The locations where we feel most confident investing our resources and risking our capital, where we see pathways, clarity, and joined up thinking around leasing, around grid, around consenting, and around revenue. And where we see a genuine commitment to investment in, as Sam said, the supporting supply chain, the ports, and the enabling infrastructure. For us at Simply Blue, for Sam and for me, those are the essential prerequisites to creating a bankable proposition.
Thank you, Hugh. Now we're going to hand over to Michael Chappell from Green Giraffe. Thank you, Michael.
Hi, good evening, everyone, and thanks for attending our floating offshore wind seminar. Great inspirational speeches that we had from Simply Blue and also from Failing. I think that now we understand very well why floating wind, why we have to make it, and why we are all working in floating wind. Now in this presentation, I'm going to show you also the how we can make it happen and how we can finance floating wind. I think that should be how it works. Yes. Perfect. So I'm just going to show you one slide about Green Giraffe. I'm going to go very, very quick on this one. It's just to show the involvement of Green Giraffe in floating wind and also how active we've been this last few years in this industry. We've done 40 mandates and closed 15 transactions so far. So I think Sam and Hugh has been very clear about where we are with floating offshore wind and the fact that it's just around the corner. The first commercial projects are really getting very close to us. In the next 5 years, the first construction should start for this first commercial project, and this is going to need a lot of funding, about $1 billion per wind farm. And for that, so far, we've seen that we haven't seen a project, floating project with project finance. And so that is something that we need to unlock to bring us a lot, much more capital to develop this floating project. So I'm just gonna go very quickly on this slide. I think that in the audience today, we have a lot of people that knows very well what is bankability, but I just want to set a bit the scene. So bankability is the ability of a project to raise financing. It's a broad concept, broader than just about banks and debt. It's also the financeability of the project and how investors are willing to invest in this project. So depending on the phase of the project, you have different type of risk. And because we have different type of risk, we also have different investor. At the development phase, you've got more equity investors. You've got also a bit of debt, but that will be debt with recourse. And then where project finance is more involved is going to be for the construction phase and the operation phase. So what investors are concerned about is the risk profiles of their project. When they do their risk analysis, they will first start listing all the possible risk and so identifying this risk on the project. Then they will look at the potentiality of the occurrence of this risk, and finally they will look at the possible mitigation. And for this mitigation, as a financial advisor, we've got usually like 4 typology of solution. We'll have the technical, contractual, financial, and also a last one is insurance that can help to cover the risk. There is a last one, and we were discussing about that with Clément yesterday, is the +1, the 4+1, and this +1 will be also the quality of the project team. As we can see a lot in our project, the quality of the project team is very important for when there are problems happening on a project, and their experience, their skill will help a lot to get around the problems. So offshore wind is very complex infrastructure projects. They have complex construction risk, a lot of interface, and also not an obvious dominant scope. That we don't have, like we can have in solar PV, for instance, one EPC contractor that can wrap up all the risk. And in floating offshore wind, like bottom fixed, it's very similar, but in floating offshore wind, we also have more interfaces risk than what we can see in bottom fixed. And so now in the next slide, I'm just going to give you a high level overview of the different risks. And then we're going to have RCG and Fieldfisher and Clément from Green Giraffe to kind of give you a bit more details on this risk. So first one is about design and certification. We know that there will be a lot of new technology involved in the first floating projects. And when we have new technology, it means that investors will rely more on the certification. They will need to have a clear view on these technologies. And that's not something that we have to be worried about, because we've seen that before in bottom fix. We've seen that there was a great technology jump to be done, and this has been gone quite smoothly and much quicker than we could have expected at the beginning. Then a very important one for investors is going to be the turbine performance. What's going to produce the energy that we're going to sell. So on this, one very big interface risk that we have is between the turbine and the floaters. And that's something that is very specific to floating wind. The floater will have an impact on the performance of the turbine. One other risk that we can see is that the choice of the turbine supplier is very important. investor will look for an experienced turbine supplier. And we know that at the moment, for small wind farms, it's quite difficult for them to secure turbines for the big three. And for the first commercial project in floating wind, they will be smaller than what we can see right now in bottom fixed, which means that it's probably going to be difficult for them to secure turbines from the big three. So that's really a risk to keep in mind on that point. Then the mowing scheme, and that's something that probably RCG will be able to talk much better about later on during this presentation. But on that, we know that it's a great technical challenge. This is not something that is easy to be done. There are very advanced technology behind that and very expensive technology. But that's something where we know that we have the experience from oil and gas. And we know that we can draw this experience from oil and gas contractors that know very well how to do that. So it's actually not a major concern because investors know that they will be able to allocate the risk. On the foundation fabrication, I mean, I'm gonna state the obvious there. Obviously, the floating foundation is a key component of a floating project. And that's what Sam was saying at the beginning of the presentation. We're not talking anymore about does this technology work. We have already quite a few pilots around here, and they've been through very harsh weather conditions, and they've been successfully facing this bad weather. So we know it's going to work. Now, the big challenge for the first commercial project is going to be the serialization of this fabrication. How we can build large-scale wind farms with multiple foundation. Once we've done so far only like few floaters and few turbines. Then one of the risks is about the electrical and infrastructure, and I think we have few insurers in the room, and they know that the cable is a massive issue, or is where we have a lot of claims in offshore wind. So that's something that we have to be very careful, especially because in floating we have dynamic cable. So that's adding one more potential issue to the cable. But we've seen that technical advisors are getting more and more comfortable about the new technology that we have here. And so that's something that is accepted more and more by investors. It's still some new technologies that will have to be vested for the first project. On the turbine assembly, that's something that is not really new because it's very similar to what we can see in fixed bottom. We have contractors that are very knowledgeable and they know very well how to do these activities. The great thing with floating, and that's for a lot of floating technologies, is that there is the possibility to have the assembly activities done onshore. So that's great because it allows us to reduce the sensitivity to weather. And so that's reducing one big risk that we have in bottom fix, and a risk that is usually quite difficult to control. And I will finish this list of risk with the operation work and the risk that we have during operation. For the same thing as the installation, it's quite similar to bottom fixed. And on that, we can draw a lot of experience from bottom fixed. There is one big difference is on the large corrective maintenance. With floating wind, there are many technologies where there will be the option to disconnect the turbine and its floater and bring it back to shore to do the work. So that's unlock a potential to reduce costs of maintenance. And so that's a great opportunity. At the same time, it's also going to create some interface risk because we're going to have to disconnect the cable. There will be the mooring installation around. So that's thing that we'll have to be careful with and bring some, it will bring some risk. So I'm done with the description of the high-level description of the risk, and I'm going to give the floor to Fieldfisher. I'm going to get a bit more in details on the aspect, legal aspect. Yeah.
Thank you, Michael. Yeah, so Michael touched on some of the risks, obviously, so I'm going to talk about how you cover those off in your contracts from a legal perspective and make your contracts bankable. So I think, first of all, it's important to look at the contract structures that we've seen in offshore to date, and we've really seen two main contract types. The first is EPC contracts, and I think a lot of people here will be aware of an EPC contract, an engineering, procurement and construction contract. And essentially your contractor will agree to design, to develop and build your project and hand it to you on a turnkey basis. And the beauty, I suppose, of EPC contracts is that your contractor will assume most, if not all, of the development risk. And for that reason, lenders like EPC contracts. They're fixed price and they're relatively low risk. But I think in the context of bottom fixed to date, we haven't seen a huge amount of EPC contracts. And that's really because contractors are not willing to accept some of the specific risks associated with offshore. So adverse weather conditions and unexpected seabed conditions. So I think it's fair to say with floating, we will see more of the second contract approach, which is your multi-contract approach. And with this approach, you essentially enter into different separate contracts with each of your specialist contractors. So you'll have a contract with your turbine supplier, your cable supplier, installation contractor, and so on. With your multi-contract approach, you can apportion your liability across your different contracts on a case-by-case basis. And the advantage of this approach is obviously it's a lower upfront cost than your EPC arrangement. But with this type, you're going to see all of the risks, I suppose, that would otherwise be covered off under one roof with your EPC contract. And Michael touched on some of these. So some of the risks we would see would be coordination issues. So by its nature, the multi-contract approach, you're going to have different contracts, that's going to give rise to different interfaces at the design, the construction and the programming stage. So how do you cover that risk off in your contract? Well, you can do a number of things. You can include a detailed interface matrix, and you can oblige all of your contractors to participate in that. You can include owners' obligations around attending interface meetings. You can include obligations around updating risk registers, notice registers. I suppose one of the most practical things you can do is put in place a really good project management and development agreement, because that way you have one person or one team overseeing all of these interfaces, making sure that everything runs smoothly. The second risk we see with floating, and again, Michael touched on this, relates to design defects and technology performance. And I think this is quite unique for floating because we're going to be moving from largely pilot projects to large-scale floating commercial projects. And so the reliability and the robustness of the technology is going to be key for lenders and for owners. The viability of the technology, as we've heard, has been proven, but viability doesn't necessarily mean bankability. So as we've also touched on, Michael has touched on, the testing methods that we've seen to date with bottom fixed will need to be adapted for floating, and that's going to bring with it certain risks. So again, cables, as Michael said, there's a lot of risk around those. So HV dynamic cables will need to be adapted, and you will need to demonstrate the reliability of those two lenders in your contracts. Again, another risk, the advantage of floating is you can obviously tow your turbine to port and you can carry out your maintenance and repair there, but that will bring with it unique risks as well for floating. So you need to demonstrate to your lenders and your lenders TA that this can be, your project can be securely connected and disconnected. So how do you mitigate against this in your contract? Well, in a nutshell, you look for really strong warranties. And some of these warranties would be really detailed. They may even be a schedule to your contract. And with certain warranties, depending on the scope, you will look for measurement test standards to be set out clearly and linked to industry standards. It's important also from a practical perspective to be aware during the term of these contracts that standard exclusions can apply. So, for example, contractors won't accept risk where, you know, a third-party contractor has come in, and we've seen that on bottom fix and indeed onshore projects. You know, you have a cable fault, you get a local contractor to have a look at it, it's fixed, there's another fault, and then you call in your counterparty and your warranty has fallen away. Your remedy for a breach of contract will be liquidated damages, LDs. So I think a lot of you here will know that's usually the subject of significant commercial negotiations in your contracts. And finally, a risk that we see associated with floating relates to seabed conditions, so unexpected seabed conditions. And it can be, I suppose, impossible to predict, despite all your surveys and what you pay for them and the time you invest in them. It can be very difficult to predict what you will find at site. And it's for that reason, particularly with seabed and unexpected seabed conditions, that contractors are just simply not willing to accept that risk. So the practical way of covering that off in your contract is to afford an extension of time or compensation for additional costs. So that's just a really, really quick, high-level look at some of the risks and how you can cover them off in your contracts. Thank you.
Thank you, Elaine. Now we're going to hear from Dan Kyle Spearman of RCG in relation to some of the technology-related issues. Thank you, Dan.
Great. Thank you very much. So I'll try and get in to some of the technical side. Michael, you've done a nice job teeing it off as well. So I'll start with the sales pitch. As always, hopefully I'm allowed. Apologies, it's been a while since I presented in front of people. It's been a couple of years, so please tell me if my trousers come down or something. So RCG, and kind of relating to the topic really, on floating wind, we support really projects up to FID, which is lucky because that is the bulk of projects at the moment. So we're kind of involved from that very early stage, greenfield, right through to FID, which is what we're starting to see for the bigger projects coming up now. So for today, what I just kind of wanted to set a little bit of context in terms of where we are with deployments, give a brief overview of costs, but then kind of get into the floating wind concepts, give a bit of a picture of those, and then also technical trends. So the challenge is to get that in 10 minutes. So feel free to ask any questions if I've skimmed over it. But I think it's kind of maybe important just to highlight where we are in the industry, because I think, you know, it was mentioned, Sam, you were mentioning, you know, the biggest projects will be Erebus, nearly 100 megawatts. But actually, what we're seeing is the development phase is really in this pre-commercial, kind of looking above that up to 200 plus megawatts. But what's not really seen is all the activity that's happening on those projects. And they won't be realized for 5 to 10 years. So I've just kind of set this as, sorry, these years are COD, so operational years. So at the moment, we're seeing demonstration and pilot projects going into the water. And then we'll see towards the end of this decade, the ramping up. So in 2025 plus, start seeing up to 200 megawatt projects, maybe a little bit later. And then post 2030, we're seeing these kind of utility scale commercial projects starting to really pick up in scale. But I think critical, Michael, you're mentioning about bankability, is needing those projects to get in the water, get that track record, and that's what's happening at the moment. And that'll quickly accelerate the size in terms of the projects, but also turbine size. And then a couple of former colleagues for Carbon Trust, so I pinched your slide here, because I think it gives a nice snapshot of where we are. We're down the bottom here, kind of 2020, you can see it's very small, sorry, 21, wrong year. Very small amount of deployments compared to what is coming. So that's the 2030 point where it's marking this big uptick when things happen. But of course, all these projects, you know, average offshore wind is 8-9 years of development time. So actually, these 2030 projects, which you can see are quite significant, a lot of activity is happening on those right now. So yeah, in terms of looking at kind of around the 10 gigawatt mark, give or take, different forecasts by 2030. I just mentioned briefly in terms of LCE. I mean, clearly, I think we all know costs are coming down. This is increasing. It was being demonstrated as projects are increasing in capacity. We're expecting that to be quite a fast reduction, particularly as you start seeing, for example, the French auctions, which is getting into the multi-hundred megawatts of capacity. South Korea again, and then of course in Scotland, larger projects, both stepping stone with Simply Blue, and then also the kind of gigawatt scale projects in Scotland. And that's what's really going to drive down that cost, combined with more competitive processes at auctions. I won't dwell on that, but probably just to kind of mention in terms of so the round ones are the fixed projects, and then the pyramids are the floating wind. So where floating wind has achieved those cost reductions, floating wind, we're expecting that to really follow suit, and if not, be even faster, because you're taking advantage, particularly of the turbine supply chain that's already there, as well as the skills. So I mentioned just trying to capture the floating wind concepts. I think this is something that's quite often mentioned, is there are a large number of floating platforms in development, which is true. So we're tracking nearly 100 of these at the moment. However, when you start breaking it down by TRL, so this is actually TRL we expect in 2024. Realistically, from TRL 7 onwards, these are the projects that are going to come into the end of the 2020s. There's a lot of other developments at an earlier stage. But sorry, TRL 7, that's a kind of a multi-megawatt or a large single turbine. These projects are going to need to be in the water operational before you go to the pre-commercial project. So it gives still quite a significant number. We're talking about 15, 16 concepts, but it's a lot more manageable than the 100. And yeah, this is kind of, I suppose, a key step in terms of understanding the technologies and the suitability of those technologies for specific sites. I mean, underneath that, of course, there is a lot of drivers in terms of site suitability, materials, mid-ocean conditions. Also, the other information is they're broken down by concept types. So this is kind of generic types. And you can see there's an overwhelming majority of semi-subs. And there's probably a few other spar and TLP. What multi-platform is really the other platforms combining wind, wave, or multiple turbines. So following on from that, you hopefully get a sense of the technologies that are coming through in the next few years. So I just wanted to, I suppose really following on from Michael's kind of given that overview of the aspects that are affecting the risk of a project. I kind of wanted to touch on some of the key considerations that I see for floating wind going forward. Interesting, for example, I haven't actually put mooring systems, but actually more for me, it's the supply chain, how we're going, because we're expecting a significant, massive ramp up, but it's not clear at the moment if supply, well, at the moment, definitely supply isn't going to meet demand. So how that's going to evolve, because we're talking about a global supply chain, multiple markets looking for the same technology. So particularly key bottlenecks, ports, fabrication, cranes, and storage. So storage, you're talking about quite sizable areas, both onshore, so that the dry side, wet side being either sheltered within ports, but also potentially offshore, where you might have areas of storing them before they get installed. I think it's fair to say there's increased both on fixed bottom and floating wind on local contents and utilizing the local capacity. So that both brings opportunities as well as some restrictions. And also, we're seeing supply chain as really one of now the major drivers in platform selection, whereas previously it was more looking at mid-ocean conditions. Obviously there's clearly other aspects, such as it needs to be able to perform as required by the turbine supplier. Of course, that's quite critical, but supply chain is really a big aspect. And of course, this is going to be something ongoing in terms of different markets going to have different approach. There's going to be hubs being depending on what the capability of countries and regions are, how those regions can work together. There's plenty of cabotage rules, which makes things complicated. So it's very market specific and very much ongoing in terms of how to deal with this global development. But as you know, it is also it's a big opportunity in terms of providing jobs locally for building these projects. Sam, you mentioned that in terms of bringing these seaside jobs, but it's also previous areas of where there's been coal mining or fabrication, all this heavy steel work, bringing potentially jobs back to those areas. And then of course linking also with supply chain, but I think it's its own in its own right, is the industrialization piece. We're not going to be able to bring those costs down and deploy at scale if we don't industrialize. So I've stolen the Model T factory as an example, but I mean it's that kind of a mentality. It's slightly more complex because we've got different markets and different platforms, but this is a real big focus platform designers are now working on, is how you can really churn these out and what the capacity or the capability is required. And what we're seeing, I think, is really important now is the government commitment. You're mentioning the UK government with the floating wind port support. This strategic investment into local capability is really critical to being able to put these, get the supply chain ready to go for it. So the Model T moment is definitely awaiting. Turbine integration, it was mentioned from a bankability perspective. It's both a commercial and a technical risk aspect, and it's something that's very different to the fixed bottom. And I think the particular aspect is bringing early engagement between the turbine supplier and the platform designer. So the commercial aspect of that, it means you have to have a slightly different approach, but it's a really critical interface on that design stage. Platform scaling. This, I think, is the age-old question in fixed bottom and floating wind is how big will they go? And it's the same, if not even more, in floating wind. Your tons per megawatt or your costs just go down the bigger you get. But where is that ceiling? So I mean, we're definitely going to get to 20 megawatts. I mean, that's pretty certain with the 240-meter diameter turbines. But at some point, it's just not going to be economic for the turbine supplier, and how are you going to handle these components? So that's going to be an interesting aspect. I had to get Boris on there somewhere. I was mentioning, the mooring systems, and actually for me, it's kind of stepping back a little bit and kind of considering more asset integrity. So this being understanding what the performance and the condition of your asset is at all times in its life. Particularly with floating wind, because you're talking about dynamic loads. I'd also call this kind of like the cradle to grave in terms of, right from the beginning. Aerospace, I think, is a really good example of this. I mean, they know exactly from when the steel is rolled, or even before that, what the composition is of every single rivet. We don't need to get to that stage or that level, but we need to know what condition the materials are as they go through manufacture, fabrication, installation, because there are quite significant loads actually even before operations. So for me, I think that's quite critical, knowing that from end to end what the condition is. And this is across the whole project, from platforms to your moorings to your cables to your turbine. And I think what's really good on this is there's a lot of tools in development. Digital twins is talked about a lot, but not just looking at it purely from a physical measurement or monitoring inspection, but also other ways of being clever about how you understand what condition your platform is. Because I think you also have to remember these floating wind is going to tend to be further offshore. Obviously, it depends on your bathymetry, but they're going to be further offshore. You want to really avoid going out if possible. So really trying to understand, without being there, what your asset is doing and its condition. linking that, as I mentioned with O&M, you know, I guess the best thing with O&M will be to do as little as possible. Yeah, so it's kind of reduction of interventions because you are in more onerous conditions. I think it's fair to say main component exchange is still a kind of an area. I would say it's kind of an area of development. You know, there's two main approaches with towing to shore, working offshore, and there's various approaches to those. And I think we'll see as projects, you know, sounds bad, but as components fail, we'll start to see how these operations are done. I mean, they're definitely very feasible, but the question is, what if you need to do a full replacement, replace all blades on a 20-unit wind farm? What's that going to look like? What's the whole process of you need to bring them back into shore? And then HSE, which I borrowed Boris with his Ocean Winds hat. I'm sure he put other hats on. We have a really good track record. Well, I'd say relatively good track record from fixed bottom, but it does bring both kind of an upside and a downside from HSE. As was mentioned, it's bringing the workload onshore in general. That's one of the big opportunities. On a kind of a counter to that, however, is it brings the work onshore. You tend to have more stakeholders involved when you're onshore, less control. Because offshore, one of the big advantages, you have really good vision. You know exactly who's going offshore and you track them. Whereas onshore, it can be a bit more. You can have less control. You know, you're on a project site rather than kind of an onshore development site, which is different. So the duty holder really has to be quite careful about selecting contractors, subcontractors, and understanding. Because at the end of the day, and that's kind of one of the challenging areas we're hearing is. When you have these projects, there's a lot of people working on them. You've got scaffolding. If you can imagine these projects being built, there's people everywhere. So it's quite a significant process. And as I said, this in-port operation does reduce weather risks, and you can have your crane capability onshore rather than needing very large offshore heavy lift vessels. But you do need the ballasting and towing operations that go with those. I think finally, also just kind of on a sort of more positive note, the Power to X. I think that's a really interesting area. So as we go to deeper waters, what it also does is it gives new opportunities in terms of new different regions. Some of those regions may not have such strong grid, and so this just gives another option to giving, let's say, kind of e-fuels. And that is my quick summary.
Thanks very much, Dan. I was interested to hear you talk about 20 megawatt turbines, and I'm probably showing my age, but when I entered this business in the late 90s, they were 500 kilowatt, the turbines, so 40 times bigger. In any event, now we're going to hear from Clement Weber of Green Giraffe, and he's going to discuss financing.
Thank you, Phelim. I hope that nobody in the room has anything against the French accent. That will be, you'll have to bear me. So double challenge. The first one is to be the last one to speak just before the panel, and the second one is that I have 5 minutes, I think, to speak about financing offshore wind, floating offshore wind, which has been something like 5,000 hours in the last few years. So challenge accepted. Sam always makes fun of me because whatever the question, I basically answer with 3 points. And I think I just do it again. I wouldn't want to disappoint you, Sam. So stealing from the slide that Michael showed. So where are we today? Where is the finance market today? And there are three answers. Where is the development equity funding? Where is the construction funding? And where is refinancing or anyone in finance, debt and equity that would enter in projects that have already been built? So the first one is during development. During development, there is no project finance. That's not the case for fixed. That's not the case for any project, and it's obviously not the case for floating. So it's not non-recourse debt. It's about equity. It's an equity game. Right now, it's fair to say that at least at early development stage and mid-development stage, the interest that we have in the market is really from the strategic players. So oil and gas companies, utilities, some of the contractors who are willing to cooperate to build and co-develop together with local developers. They are the ones who will want to buy or buy at least part of the projects that have been developed for a few years. Some of the finance players, considering that the returns in the sector are lower and lower, are more interested in coming in early and have maybe a better return. Right now, in all the corporations that we have seen, it has not really been concrete. So for the transactions that we have seen at early development stage, the pure finance players, so I'm not including GIG, Macquarie or CIP, who have a very strategic angle and strategic view in it, but the pure financial players have not been there. And the first reason is because of the risk reward. So 99% of them would think that floating plus early development is just too much in terms of risk. And the second is also that from the developer side, there is an obvious match of having a local developer with a strategic deep pocket international partner. But we are seeing more and more interest. So I wouldn't say that in the coming years, and it's more speaking about the future, we won't have pure finance players coming in the equity of projects directly, even during the development phase. So that's the first one, development. The second one is financing construction. So as it has been mentioned several times, right now, the projects that are at that stage, it's only pilot projects and demonstration projects. But we already have, from these projects, an interesting track record. And the first one is on the equity. We see the infrastructure funds, especially the infrastructure funds actually in the pure finance players, being interested in coming when the development phase is over to take part of this game. So who can take the floating risk in the same way as they were doing the bottom fixed foundations just a few years ago. The second one is debt. Debt, so Michael mentioned it. I think pure non-recourse finance debt has not been raised so far. We have Windfloat Atlantic and King Cardin who have raised debt, but I wouldn't qualify it as pure non-recourse. But we have gone through this full analysis together. Some of the banks have done it as well. I think from the 45 banks that are currently active in bottom fixed in offshore wind, we have around 10 to 12 banks who have already gone through their credit committee to approve floating offshore wind as a sector. So the market is there, but it will be there only for the projects that have gone through the full analysis and have the right mitigation measures in place for each risk in the same way as Michael explained. So that's the debt. And then last part, and I only have 30 seconds left, but it's good because basically on operation, it's still only a few projects that have been built and that are building. Maybe the only comment there is to say that compared to bottom fixed, where it's very much a race to the bottom, at least in terms of return expected for the projects that have been built and are in operation, there is an interest also from strategic players to enter into the projects that have already been built. And the reason for that is not a financial reason. It's just to get access to the IP, to get access to, well, how a project performs and operates in floating. So there is, the conclusion of everything is to say that there is a market already at any stage of development for floating. It's a market that is still small compared to what we see in offshore wind. We will need, for the billions to come, we'll need it to be much, much bigger. But from everything that we see, we're going to the right direction. Thank you very much.
Thank you, Clement. So now we're going to have a panel discussion. I'll maybe kick off with a question here for Sam. So Sam, over the last 10 years, the UK market has emerged as a leader for fixed bed offshore wind. And so what I will ask is, what 2 or 3 jurisdictions would you see as being market leaders in the floating wind space over the next decade, and what advantages would that have for the local economy?
I obviously didn't do my homework well enough because I thought it was different, the second part of the question, but anyway. Coming up in the lift, I saw from COP today that there's 10,793 turbines in the UK. So I think the UK being the leader in fixed and also being the leader in the 2 pilots that are here at present is obviously going to be a huge market. I think the second market, we refer to it in the US and the West Coast, just because of depth and just because of the ambition in America. How much you kind of agree with me there? Yeah. Would be second. A third market, you've asked for 3, isn't it?
Yeah.
Okay. I think a third market is
more.
Sorry. And I think probably need to go to the Far East, I would say, is the third market in 10 years' time. And whether that's South Korea or Japan or, but I think that's where where my gut would be saying would be the leaders. But there's huge opportunity right across the board, but I would put them as the leaders. Second part of the question was the bit that I didn't get beforehand, and that was
what benefits would accrue to the local market where you do have that?
Okay. So what I just explained the other day what a floating wind project is, and if we split it into 2 parts, the development side, and at present, and listen, there's all us fellas up here, Lane, you're the only lady up here. I'm glad to say that we have a little bit better gender balance in Simply Blue, but that early stage is we've got people out at the moment carrying out surveys, etc., going through all that pre-development. Then we're getting into the construction phase. And that's shipbuilding. That's what these floaters are. They're big ships. And what I said in Glasgow was the devastation caused in the 60s or across the water in Belfast with the demise of the shipbuilding. And this is what we need. Of course, yes, there's infrastructural challenges, and we need to have deeper waters. We need to, look at the loading capacities of lay-by, etc. And I think, Dan, you referred to physical space that's going to be required. But what we need is we need welders, we need joiners, we need fitters, we need electricians. Then we go to the next stage, and that's the operations and maintenance, and what we're designing now for 30-year lifespans. And in that, it's not just engineers from the university here in London or whatever it is. It's, as I said the other day, it's the local mariners and it's the local fishermen that have been to the University of the Coast, the University of the Sea. These people know the tides, the currents, they know the winds, they know the locations better than anybody else. We can't learn that. We got to realize this. And we're going back to, the 13 families in our small village, now 1. And that's a challenge because the last generation that hasn't been passed on from generation to generation. And that's going to be a huge requirement. I think the other part of that is also their equipment and the vessels. They're fishing in these areas and we need those vessels. Yes, Dan, we're going to do as much as we can autonomously. And, we were out last week looking at Kincardine, and the swell was 2 meters. And, we have second in the Irish Navy working with us, and even he said it was rough. And so we got to realize the challenges. So these people, these local community, that just transition, I think, is a huge piece of the fail.
And do you want to come in on that question, or anyone else?
No, I think I would agree with at least on the first part of the question. Clearly, maybe just to add to this, what has been very positive recently in terms of the countries and the areas in which floating has been developed is that it initially has been developed in countries who had no choice. Just the coast is too steep and the waters are too deep. So we saw Japan, South Korea, the west coast of the US, Mediterranean Sea being leading it. I think what is very positive is that some of the countries like the UK indeed are now entering into that game. They really want to develop floating as well. and they will be the link, they will be the bridge between all the experience that has been built in traditional offshore wind or fixed offshore wind and floating. So that would be maybe just to add to that, but otherwise saying clearly Europe, the US, and Far East are the three areas. On local content, I'll let the developers with the answer. Nothing to add.
Not a developer, but I think maybe just to add, I mean, one of the big advantages for me when you start looking at what the benefits are to economies is the flexibility you have in the floating wind solutions in terms of how you fabricate them. So you can look at steel, you can look at concrete, you can look at kind of a combination of both. It can be quite modular, so it really opens up to whatever the supply chain and what that country is looking for, you know, whether they want it fabricated in one area or multiple areas. There's a huge amount of flexibility there.
Just one last point, and maybe it's not local supply chain as well. I don't know if we touched on it, but I think, you know, with floating, we're going to the best wind resources. We're not constrained with depth. And I think that what you're seeing is the capacity factors that are coming out of Scotland. You know, we're all going, wow. So that's a huge positive for floating.
Great. Sam, while you have the mic, and I hope I could be heard, can you talk a tiny bit about Ireland? And I know I'm sort of raising the Irish flag there as an Irishman, so forgive me. And I hope it's of interest to people, by the way.
I didn't want you to ask me that because I didn't want to tell all my competitors in here what a wonderful place it was. So listen, we're, you know, as an island, if we look at it, and as a people, we've looked in. The marine space is 10 times our terrestrial space. Delighted with our present government that they have an ambition, or they've set a target of 5 gig by 2030, but also in the program for government is 30 gig off the west coast. So we have an incredible resource. We don't need the power, all of it. We need a lot of it because we're going to decarbonize our island. I think the big challenge about Ireland is how do we get those electrons to the market? How do we get it to Ruhr Valley? Is it going to be, you know, connectivity, superconductors? Is it going to be, Dan, you had the IRM Dolphin solution, or is it going to be molecules, or is it going to be something else? There's one thing I'm absolutely sure of as living on the coast, and for my children and grandchildren, is I think it's like being in Aberdeen or on the west coast of Norway in the 60s. This huge resource will be harnessed, and we've got to make sure we harness it the right way.
Now I'll address the next question to Clement. Clement, you spoke about non-recourse project finance and there not being any yet. What does it take for a bank to provide non-recourse finance to a floating offshore project?
Yeah, it's a question that we can talk about for hours, but I'll try to be a bit quicker than that.
But you'll have 3 answers.
Yeah, exactly. No, I think maybe just to mention indeed, so when I say nothing has been done, obviously you probably have seen in the press, Windfloat Atlantic said they have done it. Actually, indeed, EIB has provided debt for the construction of the project, but under a full cover under EU scheme. Kincardine also raised a debt specifically for their project, but with recourse to ACS Cobra. In the French pilot projects, some are currently in the market. It's public knowledge, so that might come soon. I think we need 2 things. The first one is we need the projects, and you know, if you just look at the curve that Dan showed, we're still with only a few projects that have reached the point of financial close, what we call financial close, which is basically the start of construction. So we just need more projects to reach that point. And then we need to do the analysis that Michael presented of looking at the risks. What is the chance of occurrence? If they occur, what is the cost for the project? And then once we have it, can we mitigate them? Can we give them to somebody else, to an insurance, to a contractor, or is there any financial mitigation like cash sweeps, reserve accounts that have been used in the early days in traditional offshore wind and fixed offshore wind? So that list of risks and how they can be mitigated is how the banks would look at it for any sector. I think for floating, because it's new, it needs to be even more detailed than it is for a mature sector, where you can compensate the detailed analysis a little bit by saying it has worked before, look at the track record. Here we don't have this, so each developer who wants to attract project finance would need to go through that very detailed list of projects, hire the right advisors, legal, technical, financial, and then, as I said, with this in mind for the projects that have correctly mitigated the risks, I think the project real non-recourse finance would actually be available right now in the market.
And what banks would you see as being the leaders in the space? Who's moving the quickest towards
it? I would say the traditional project finance banks. So it's for once it's a space where the US are actually lagging behind. So the Japanese banks and European banks, especially French, Benelux, have been very active 15 years ago in fixed offshore wind. I remember when I arrived in the UK in 2011, where everybody said project finance for fixed offshore wind, it's not possible yet, and we already had closed 5 wind farms in continental Europe. So definitely these banks have been leading the fixed sector, and we see them again in floating.
You don't want to name names.
Well, yeah, I can. The BNP Paribas, Société Générale, MUFG, and SMBC. I can name
Everyone got that
many.
one.
Yeah. 3 hours later.
Sorry, if I could just return to a legal topic then, Elaine, for you. What would you see as the key differences, and maybe give us 2 or 3, between the legal risks associated with fixed bed versus floating wind?
I think Tom touched on some of them there. I mean, I think with fixed bottom, we have a structure now, we have contracts that lenders are relatively comfortable with. But I think when we move to floating, because the technology is so new, there's going to be a nervousness around the reliability and performance. And I think the warranties that are currently maybe in your fixed bottom contracts may not necessarily go far enough for floating. And I think we're going to see, particularly for the early large scale projects, I think lenders are going to look for, they're going to look at firstly who you're contracting with, what insurance arrangements they have, and maybe where they may take a view with fixed bottom because they're comfortable and it's a proven technology, they may not be willing to accept any risk, particularly for the early projects. So I think we're going to see much, you know, a lot of focus on contract counterparties and the insurance arrangements they have in place and the warranties that they're willing to provide.
Great. Sorry, okay. Cameron.
Yeah, sorry, I was raising a Zoom hand. It's a new world. No, I just wanted, I mean, it's difficult in these, you know, in the discussion and in these conferences to see at which level we obviously want to provide the high level answer, and getting too much into details would be boring. But it's really, I think what is important to understand is that, so everything that you describe in floating is different from fixed, also because of the interface between the turbine and the floater. So in bottom fixed, just to take for example the O&M contract, the banks have banked fully non-recourse projects without having the O&M for the foundation in place yet at the beginning of construction. So okay, that will be done. That will be done later. So 100% of the focus of the banks in bottom fixed for the O&M part has been about the contract of the turbine. Now it's not possible anymore for floating, because if the floating foundation is too unstable, then it's not the fault of the turbine supplier. So basically, it needs to be compensated through damages by the floating parts. So suddenly we have, instead of looking at what is the right damage to be paid or compensation payment to be paid by the turbine supplier to the project, to have three parties making sure that whatever happens, it is covered by either of the parties. So the interface risk and the gap analysis is much more detailed, and it goes as detailed as looking at the formula. What is the move of the floating, and when it is taken by the turbine supplier, when it's not, and how the compensation works. So it's just maybe to give one example that it's more difficult for floating than for fixed party.
Sorry to be constantly handing this microphone back and forth.
Very convenient.
Yeah, very convenient. Thanks, Dan. And if I could ask a question of you. There are three operational or floating offshore wind farms: Kincardine, Highwind, and Windfloat. What lessons have been learned from those to date in terms of their operation?
Great. Yeah, I think it's a good question. I mean, I'll not get too close. And it's kind of vital to unlocking those future projects, because of course you need, I mean, we were mentioning in terms of track record, needing the operational experience. So that's one aspect, is the essentially seeing that they're working. I mentioned about no one having done tow to port maintenance or heavy maintenance. That's because it hasn't been done. The turbines have been operating as expected, and there haven't been any main components. So that's kind of probably the first thing, is they're working. And I think probably mentioning capacity factors. Highwind Scotland, I was having a quick look earlier, is 3 years in a row they've been the highest capacity factor in the UK as a project. So I mean, it's a windy place, Scotland, but still that's impressive that it's technology, new technology that is providing those kind of returns, and that gives real confidence for the future projects. Then I think also kind of the whole supply chain as well, as I mentioned, kind of getting them fabricated, towing them, all the various operations to get them offshore, showing that the success of those, I think, has been important. Successes and the challenges as well. Being honest, I mean, they're not. There's always things that they find out, and that's where those leading the floating platform designers who've been involved feed those back into their design. Windfloat is on version 3 at the moment. Just as an example, they're going through those iterations, and I think they have version 4 probably in the planning. But that's all part of that learning, and that's critical from Kincardine as an example.
Can I just throw one other one in there? It's more grey actually, and if I take out my phone here, I've got the video of being out to Kincardine, and when you're meeting with legislators and you're meeting with officials, that they have to make decisions, and they actually see it real. It makes a big difference. It's not still on the drawing board, and it suddenly goes up the priority list. It's like, wow, it is really happening.
So Sam, can I ask you a blunt question? When is Simply Blue going to start building its first project?
You. So Erebus is, we're on plan for CFD around 2023. So the intention, and with our partners Total, is to get to operation as quick as possible. Will we make 25 now? 26. Yeah.
Okay, so what I might do now is open matters to the floor. So if you have questions, can you please raise your hand? And it'd be great if you could just say your name and what organization you're from. Anyone want to start? Yes, gentleman here, the glasses.
My name is Simon. I'm working for RWE Renewables. One question Jen mentioned is actually during the panel, the comparison between floaters made of steel and concrete. So I'd be interested to hear a bit more about that. What aspects have to be considered? Which which type of technology you think would prevail?
That's a straightforward question. Sounds like it's similar. It's quite, yeah. To be honest, I mean, I think it really depends on where you're talking about. I think it's as much a supply chain question as a technical question. I think Maine, as an example, they're going to be building theirs in concrete and looking to build out more of those. And I think, yeah, so technically it can be done either way. I mean, I think there's more track record with steel at the moment, but that's just because that's the initial projects, and as you mentioned, they are ships essentially. So that's where the steel and concrete, there are concrete ships, believe it or not, but they are less out there. In terms of which is going to be the optimal solution, I mean, yeah, I think time is going to tell, and it'll depend on kind of, I suppose, how the realization of those projects are going to be. So you wanted to?
I was just going to say, I think all of the above, Simon. I think we need all of the above. I mean, when if you just look at ScotWind and 7 megawatts, let alone going, and you look at the constraints we have in ports, etc. So there's obviously huge positives with concrete, but I think all of the above is going to be required. I think that the advantage, obviously, Dan, as you said about steel, certainly in Europe at present, is there's 3 pilots that are out there working.
I think just in terms of very specifics, interface, steel concrete interface is probably one of the biggest challenges with them, and kind of the implications that has, and also the size of the unit, and also actually quite a considerable amount of steel is needed. So I think it's going to be somewhere kind of in between. So you'll see kind of more of a hybrid steel concrete to give you flexibility in your supply chain rather than going full concrete. But yeah.
Hey, anyone else for a question? This gentleman here.
Yeah, Parth from Octopus. Kind of related question on, you talked about industrialization and why that's important for floating, but how about standardization across the different floating technologies? How important is that? Do we think we will have it all narrowing down to 2 or 3 key kind of designs in the future, or is there room for many different technologies and design in different parts of the world?
Do you want me to say that one?
Elena, let's go.
I think it's there's going to be different phases. As I mentioned, the kind of those ones on the right side of the TRL, the most mature ones, they're going to be the technologies for up to 2030 and even maybe 2035. So you're talking about kind of a handful of concepts. I mean, I think there is going to be appetite for. It's not going to be like fixed bottom where there is one solution at the moment, roughly. There are more solutions coming in, actually. It's quite interesting that space between fixed and floating, there's a good bit of competition now. But I think it's going to be different, and it's going to be much more of a, imagine building a fleet of ships. I think it's that kind of approach where as a developer, you say, this is my spec, you go out to tender for it, and then I think what you're going to see though is the EPCs will be much closer with the platform designers. So providing that whole package, saying, okay, this is what we can do, then they're picking up the warranties, liabilities, etc. as their parts. So it's a lot more wrapped up. So I think that's going to be the way it's going to evolve. So not necessarily sort of consolidation in the sense of those platform designs will be brought in with EPCs. But I still think there is going to be appetite for kind of different designs. That's my.
So from a developer perspective, does it make it a bigger challenge? You have so many different sort of technologies and concepts out there, or is it a bit of a no-brainer for any given project of seabed conditions or coastal conditions?
Well, it can be there's obviously some site specifics. We're not going to use a spar in a lot of the locations we're going just because of depth constraints, but I nearly put it in buckets. There's semi-submersible, and that's the concept. And there's TLPs, that's a concept. There's spars, and you can go across, but I think I nearly put them in those buckets.
Yeah, maybe just to add on the commercial side, because I think for one project, the standardization is actually better for floating. Obviously, in bottom fixed, the dominant technology has been the monopile. And when you do it on a sandbank or wherever, the size of the monopile is different for each location. Whereas for a given interface between one turbine and one floating foundation and one site and one specific site, it can be the same floating foundation or similar floating foundation for all. So for one project, I think there is a case to say that it's better for floating than for fixed. The issue that we have currently, and I think you mentioned 100 different floating designs. I was still counting 50, so I'm clearly behind. But that's a real challenge that is also related to what Michael was saying. For each turbine supplier, they need to look at the specific interface, not only for one site, but also for one design of the floater. And it's 100 different designs, but also each design is basically improving, changing right now because we're at the beginning of the sector. And that's why it's a lot of time. And that's why basically they say, well, for a 50 megawatt project, I wouldn't bother. So I think everything is linked, and definitely being able to see in the coming years the 10 main technologies and having the main turbine suppliers having done and invested the time in looking at the interface between the two will help tremendously to harmonize and to deploy it at a larger scale.
It made me think also something, because the turbine suppliers is so critical. One of the leading turbine suppliers has a list of 5 platform designs that they will engage with. So I think that's your answer. I mean, yeah.
Yeah, and I think, so I was just going to say, if we were technology companies and we're starting here and we're trying to raise money from you guys, here's a big problem. Where are we going to get turbines for our technology? And you need more technologies coming through, but that's just a practical problem. Yeah.
Anyone else got a question? No? Yeah, gentleman here.
Paul Fumica, Park Renewable.
I got
question on local content. How you see these requirements as an element that could make more difficult the bankability of the project per se? And as you indicated, sort of parallelism between the early days of the bottom fixed foundation and today for floating. If at the early days of the fixed foundation, the developers suffered the same local content requirements from the
I might start in one bit of it, and I think it's a challenge for, if we're here in the UK, is do we want to have local content or do we want to have cheap electrons in certainly in this decade? And you can't have both. If it's going to be driven by, really competitive CFD auctions, then we can't compete here. So whether it's leveling up or the just transition, or even looking at the bigger picture and creating that local supply chain so that it can compete long term, I think there has to be support. But British government can't have it both ways.
Yes, and I think the question between local content and bankability, it really depends where in the world. So the usual question that we have, and issue or challenge at least that we have here around the North Sea, where we already have all the skilled workers and all the companies from bottom fixed, is really a question between local content and cost. In terms of bankability, it's not really an issue. In a sense, it's even simpler to finance local content than something that would come from China. Indeed, in the new countries, so the countries that have not developed the bottom fixed projects, it becomes a real issue, and indeed a tension between bankability, which is really related to the risk, so between the risk and the local content. So if a new country, then even in the US, when I say new country, it can even be the US, for that. Says, well, I want everything to be manufactured from US companies, US boats, and so on. Whereas a lot of the knowledge and the expertise of floating offshore wind comes from bottom fixed that has been developed around the North Sea. Then it's a higher risk, and then it can become a bankability issue. So it really depends from which point of view. Here in Europe, I wouldn't say there is any difficulty around bankability because of local content. It's really about cost.
So one final question. It's a very, really quick question. It's 2050. Okay, what proportion of all offshore wind in the world is floating? Okay, you can just give one number, not three answers now, Clement. So one number and then pass it up.
Wow. Wow. So 80% of the resource is deep. One number, 50%.
I'll go with 40.
I go for 60.
I'm going to go with 50.
Great. Okay, guys, we've had a very interesting debate. We are going to have to wrap up. I'm getting all sorts of signals from the back telling me to finish off. So I'd just like to thank everyone for their attendance, and especially those on, not especially those online, but including those online. We who are here are going to continue the debate outside over a glass of wine and a bottle of beer. So if you're at home, why don't you crack open a bottle of wine or a beer or a little glass of sherry and toast our good health. But anyway, thank you, everyone. Cheers.